So the next thing we need to talk about with ionic compounds is the polyatomics. What we've been talking about up until now are called monatomics, and that is because they just have single atoms bonding with single atoms. But there are some situations in which more than one atom can bond together into kind of just a block of atoms that have a specific charge and act like a single atom. Now you have a sheet that was handed out in class that has, a couple dozen different polyatomics. These 7 right here are the ones that you need to know in class. These are the ones that you need to memorize. And a polyatomic, all it is several atoms bonded together that act like a single atom. So poly means many, and then atomic refers to the atoms. So a polyatomic is several different atoms bonded together, and they end up with an overall charge, and they act like a single atom. So for example, nitrate. Nitrate has a nitrogen and 3 oxygens that bond together as a single unit, and they have a -1 charge overall. Carbonate has a carbon with 3 oxygens, and overall it has a -2 charge, and all of those are going to bond together. Phosphate is PO4, it has a 3 negative charge. Sulfate, SO4, all of those bonded together have a 2 negative. Acetate's kind of interesting because you have C2H3O2. There's a lot of different atoms there, but overall this chunk of atoms has a -1 charge. Hydroxide is a really common one that we use a lot. OH, it has a 1 negative charge. Then we have ammonium, which is actually a positive. So you have nitrogen and you have 4 hydrogens, and you end up with a +1 charge. So your polyatomics are going to bond just like single atoms do. So let's just say that we have, let's say we have sodium nitrate. Okay, so what we have is we have sodium bonded with the polyatomic nitrate. It is important to be able to recognize this. When I say memorize these, you need to memorize the name, you need to memorize the formula, and you need to memorize the charge. Because it is important that when you look at this, you see this and you say, okay, sodium nitrate. All right, nitrate is this NO3. So sodium is here on our periodic table, and it is in column 1, so it has a +1 charge. So we have our sodium with a +1. And then nitrate is NO3, and it has a -1 charge. Okay, so what we have is one sodium atom bonding with the nitrate ion, the nitrate polyatomic ion with nitrogen and 3 oxygens. So we have a +1 here and a -1 here. We're still doing ionics, and so we still have the charges to worry about. So we have 1 positive and 1 negative. So what we have is sodium nitrate. Now what if we have calcium carbonate? If we look up calcium on our periodic table, calcium is an alkaline earth metal, and so calcium has a 2 positive charge. Carbonate is CO3, and it has a 2 negative charge. And so again, we have 2 positives and we have 2 negatives. So we need 1 calcium and 1 carbonate. So we write it CaCO3. What if we have sodium phosphate? All right, sodium up here is Na. It has a +1 charge. Phosphate is PO4, and it has a 3 positive charge. So in order to balance this out, we would need more positives than we have. Oops, this is negative, sorry. Negative. So we have 3 negative on our phosphate, not positive, and a +1 on our sodiums. So in order to balance out these 3 negatives we would need 3 positives. So to write sodium phosphate, we would have sodium 3 phosphate. Now what if we have calcium hydroxide? Calcium, we decided, was Ca, and it has a 2 positive charge. Hydroxide is OH, and it has a 1 negative. So we have 2 positives and 1 negative. That means that we need another 1 negative. So if we were to write calcium hydroxide, we would need 2 of these. Now, this is not correct, and can you tell me why? If we put this 2 as our subscript right here by our H, what does this tell us? This tells us that we have calcium, oxygen, and 2 hydrogens. So we would have something bonded like this. Okay, so we have 1 calcium, 1 oxygen, and 2 hydrogens. So our compound would look something like this. This is not 2 hydroxides. This is 1 oxygen and 2 hydrogens. Hydroxide is OH. So to write this correctly, we would need 2 hydroxides. To show that in our compound, we would put parentheses around our hydroxide. So 2 outside of a parentheses shows that we have 2 hydroxide ions bonded to 1 calcium. Okay, so you see how this is different. This has the 2 hydroxides, the full hydroxide ions. This does not. This has 1 oxygen and 2 hydrogens. And since our hydroxide is 1 oxygen and 1 hydrogen, if we have 2 of them, we need 2 of that whole thing. So the correct way to do this, if you have 2 or more polyatomic ions in your compound, if you have to balance this based on the charges, if you need more than 1 polyatomic, you need to put that polyatomic in parentheses. So if we were to do, oh, I don't know, let's do barium acetate, just because. Okay. If we have barium, if we look at barium on our periodic table, barium has a 2 positive charge. Acetate is this really long one, but it only has a 1 negative charge. So the same thing happens here. We have 2 positives, but only 1 negative. So we need 2 of those 1 negatives. So to show that, we would have to put that acetate into parentheses and put a 2 on the outside. Now the question becomes then, how many atoms of each one do we have? Because this is kind of interesting as well. If we look at our barium, how many barium atoms do we have? Well, we have 1, because there's just 1. If we look at our acetate ion, we have 2 carbon atoms in 1 acetate ion. And how many acetate ions do we have down here? If we have 2 of them, and if each one has 2 carbons, we would take this 2 times 2, and we would have 4 total carbon atoms. So if we were to write out 2 acetate ions, we have 2 here, we have 2 here, we have 4 total carbon atoms. If we look at our hydrogen, in 1 acetate ion, we have 3 hydrogen atoms. And if we have 2 of them, we have 3 here, we have 3 here, we take that 3 times 2, we have 6 total hydrogen atoms. And then if we look at our oxygen, in each one of our polyatomics, in each one of our acetate ions, we have 2 oxygens, and we have 2 of them, so we would have 4 oxygens. Okay, so when we look at this, a lot of times when we do things like molar mass, it will ask us how many carbons do we need, how many hydrogens do we need, how many oxygens do we need. The number inside the parenthesis and the subscript outside the parenthesis get multiplied. Okay, so we're looking at multiplying those subscripts to figure out the total number. And you can write it out. If you look at this one, we have calcium here. We have 2 hydroxides. This means that we have 2 oxygens, 1, 2, we have 2 hydrogens, 1, 2. So you can write this out. If it helps you to write out that structure, to kind of visualize that, you can sure do that. All right, now what if we want to name them? What if we have, let's see. If you come across something like this, and you're given this particular compound, here is what is incorrect. Here's what I get a lot, and it is not correct. We will write down barium, sulfur, oxide. This is wrong. This is no. Do not do that, because you need to understand that this is a polyatomic. When you see SO4, this is where that memorization comes in. This is an automatic recognition that this is the sulfate ion. Okay, so SO4 is sulfate. So we would call this barium sulfate. Okay, it is important to be able to recognize that. One of the hints with that, if you are doing an ionic compound, you will never have more than 2 names. You will never have barium sulfur oxide. You won't have 3 elements listed. You will have barium sulfate. So that's kind of a hint. If you start to write something and you're on your 3rd ion, that's not correct. So for example, if we have, let's just say we have this. Okay, here's another clue. If there's something in parentheses, it's a polyatomic. All right, so there's a couple clues there. If you have more than 1 element listed, or more than 2 elements listed, it's got to be a polyatomic. If you have something in your parentheses, it has to be a polyatomic. So coming over here, we see that it's nitrate. Sr is strontium. And NO3 is nitrate. So we have strontium nitrate. Now what if we have this? Here's a good one. What if we have copper and sulfate bonded together? So we could look at this and we're on a roll here, and we know that this is sulfate. Okay, we've got these memorized. We know that this is sulfate here. So we have copper, sulfate. All right, now what's the problem with this? Why is this not completely correct? What have we missed? Well, we know copper is a what? Where is copper located? Copper is one of our transitions. So in order to name this one, we would have to look at the charge on sulfate, which we have memorized because we're doing good. We have a 2 negative on our sulfate. And if we only have 1 copper, it must be a 2 positive to balance out that 2 negative. So we have copper 2 sulfate. Should we do another one like that? What if we have iron oxide? Okay, we have our iron. And we know that we have hydroxide. I think I said oxide, didn't I? That's hydroxide, not oxide. So we have iron, and we have hydroxide. Iron is here on our periodic table. It is a transition. So hydroxide has a -1, and there are 3 of them. So that gives us a 3 negative charge on our hydroxides. So we only have 1 iron. That must mean that we have a 3 positive charge on our iron. So we have iron 3 hydroxide.